Imagine walking into a massive library, but instead of being organized by subject, it's organized entirely by, like, vibes.
Right.
You ask for a book on quantum physics, and the librarian hands you a sci-fi novel, a cookbook for quantum soup, and an actual physics textbook, all because they share a similar, aura.
Yeah, it sounds funny, but, well, that is exactly what's happening inside most enterprise AI systems right now. It's the illusion of the weekend hackathon.
Okay, let's unpack this. Today we're digging into a stack of notes and this really intense architectural spec called the vector trap.
Oh, yeah, it's a good one.
Right. And our mission for this deep dive is to figure out why entry-level AI setups, specifically naive Arge, just completely collapse when you try to run them in real-world production.
Yeah, because if you follow a standard tutorial, it tells you to, slice documents into fixed 500 token chunks, use pure cosine similarity to find semantic matches, and call it a day.
Which works fine on a small scale, right?
Exactly. If you're only querying a 200-page PDF, it actually feels like magic. But the spec points out you eventually hit a brick wall.
The 50,000 chunk wall.
Yes. Once a company's data scales past that, latency spikes, precision drops, and your vibes-based library breaks down into what they call semantic collision.
Okay, so why does size break the system so badly?
Well, to understand why, you really have to look at the mathematical reality of a 1536-dimensional embedding space.
Oh, wow.
Yeah, it's when you process that much data, you get this geometric crowding effect called the Hubness problem. Basically, domain-specific corporate data naturally clusters tightly within a very narrow subspace.
So instead of a whole library, every single document gets crammed onto one shelf labeled corporate jargon.
Pretty much, yeah.
Yeah.
And that causes topological smearing. Distinct operational contexts end up sharing identical vocabulary, words like compliance or escalation threshold.
Right.
The fixed vectors just collapse those nuances. The spec actually highlights a chilling example.
Okay, I'm listening.
An active Q3 2024 policies scores a 0.892 similarity, while an obsolete Q1 2022 policy scores 0.891, simply because they share identical jargon.
Wait, really? 0.892 and 0.891? I mean, that is basically a coin flip.
It is.
So if an employee asks a question about their benefits, the AI could hallucinate an answer based on a deprecated draft from 3 years ago just because they use similar words. Vectors don't natively understand time or authority, do they?
No, they don't. That's called temporal vector drift. The dense embedding space cannot natively distinguish between today's rule and an old draft.
Wow.
This is exactly why pure vector RAE is architecturally dead for enterprise production.
Okay, so if the one-shot vibes lookup hallucinates, how do we actually fix it?
The architecture has to evolve into a multi-stage pipeline. So first you move to hybrid search.
Okay.
You don't ditch the conceptual search, but you pair it with sparse BM25.
And what exactly is sparse BM25 for those who might not know?
Think of BM25 as your hyperliteral librarian. It doesn't care about the vibe or concept of the book. It only cares that the exact serial number, UUID or error code, matches what you asked for.
That makes sense. But how do you combine vibe search with a literal search?
You unify them using Reciprocal Rank Fusion, or RRF. By setting a constant K mathematically, usually around 60, you smoothly blend the top exact keyword matches with the top conceptual matches into one list.
Okay, so now we have a blended list of good candidates, but how does the AI know which of those is actually the most relevant to my question?
That requires the next stage, which is the cross-encoder.
Ah, okay.
Standard search engines calculate the query and the document independently. A cross-encoder acts as a ruthless referee. It takes the top 50 results from your blended list and evaluates the user's query and the document simultaneously.
Oh, across deep cross-attention layers, right?
Exactly. It analyzes the exact token-level interactions, and we strictly drop anything scoring below a 0.65 threshold.
I love the idea of a ruthless referee. But wait, if we're pulling all these massive corporate documents to find the perfect match, won't that just completely overwhelm the AI's context window?
Well, that is where the third stage comes in, hierarchical structuring. You don't search giant documents. You search highly granular child chunks, maybe 100 to 150 tokens.
To get a pinpoint semantic hit without dilution.
Right. But you don't hand that tiny fragment to the AI.
Ah, let me guess. You give it the parent.
Precisely. You fetch the 1,000 to 2,000 token parent document store it originally came from.
Oh, so that ensures the language model receives the actual contextual coherence, like the headers, the dependencies, and the surrounding logic.
You got it.
That is brilliant. But even with this perfect three-stage pipeline, what stops us from pulling up that outdated 2022 policy we talked about earlier.
Hard physical limits. You never rely on the embedding vector to determine temporal validity. You need SQL metadata pre-filtering.
Bringing it back to the library, this is like putting a padlock on the door to the archives that hold the 2022 documents before you even let a user ask a question.
Exactly. You enforce a hard database constraint, like document status equals active, before you even calculate a single vector.
Oh, okay. That's smart.
Furthermore, you implement circuit breakers. If that cross-encoder referee says its top score is below a point-sickle confidence threshold, you short-circuit the pipeline.
And just return a structured fallback response rather than letting the system guess.
Right.
And I imagine ingestion is just as critical. The notes mention using cryptographic hashes of the raw text. When a document updates, you have to use that hash to systematically prune the deprecated nodes, right?
Yes, because if you don't deduplicate, you're just piling toxic waste into your vector store.
Mm-hmm.
Which brings us back to the reality of production.
Right.
Scaling this is not about tweaking embedding model parameters or buying the newest foundational model. It is it's a brutal traditional systems engineering challenge.
So, what does this all mean for us? We started with that massive library organized by vibes. It turns out fixing it isn't about magically training a smarter librarian.
No.
It's about building better shelves, rigorous catalogs, and strict checkout systems. Which leaves me with this thought to kind of chew on. If scaling enterprise RH is fundamentally a traditional systems engineering challenge, how much of the current AI industry is pouring billions into optimizing the exact wrong layer of the tech stack?